Hello and welcome back. Now, with this last video I did on this 23cm preamplifier, surprisingly got a large number of views in a fairly short time. I think it's up to 1.5k now, and that's rather unusual for something like this to get that many views. But I must say thanks to all the people who commented on this video and suggested what it would have been used for. And I noticed there were several saying that it would have been used for ATV reception, amateur television reception. And then I got an email from a very nice guy in the Netherlands with a link to his electronics magazine where this project appeared. So it was really kind of him to send me that link, and having downloaded the whole magazine, I found the article in there, and that's exactly what it is. It shows you the construction of it, the schematic. The only one problem with that though, I can't read Dutch. I tried to translate using Google Translate, which will translate a PDF, but it will only translate documents of up to 10 megabytes, and this magazine was 21 megabytes in size, so that was a failure. So this morning I've been trying to find a PDF reader where I can extract certain pages from that PDF. And I did that. So now I had just the article and none of the other stuff in the magazine. So a much smaller file size. So once again I tried Google Translate of a PDF. And it sort of worked, but it didn't get rid of the Dutch words. It just printed English words on top, and it was virtually impossible to read either the Dutch or the English. So that was a bit of a waste. So I've given up basically. I can get the gist of it by looking through this article. And as I was saying, the guy in Amsterdam said it was for ATV reception on 23 centimeters, and the reason it has so much gain, well over 30 dBs of gain, is that it would normally be used with a satellite television receiver, which normally get fed by an LNA. Well, the signal's mixed down and then fed down into the receiver from the low noise block. And these satellite receivers cover a fairly wide bandwidth, and they cover 23 centimeters. So using this little box preamplifier and a satellite receiver, maybe that's why they need a high gain, because it's expecting a large signal from the LNA normally. So that's that one. So thanks again to everybody who commented. Very interesting comments. I try to answer them all, but sometimes I fail. I'm only human. And as I got more popular, it's getting harder and harder to answer all the comments. But one thing that was interesting, my original assumptions about what parts were which were fairly accurate. I got a couple of things wrong. For instance, the device on the input is a gas FET. It's an MGF 1302. Quite an impressive device, and I'll show you later its characteristics. And then of course it's going for this bandpass filter. But there's no lack of gain coming out of here, I can tell you that. I'd estimate that's got about 20 dBs of gain at this frequency, because that device is designed to work up to 4 gigahertz, I think. So you're going to get a bit of loss through the filter. Could be 6 dB, could be 10 dB, whatever. Apologise for the light, but I'm not in the workshop. I'm in the house, because I want to look at this computer screen for one thing. But I was right about a couple of other things. The next device is an MSA 0685 by HP, or as it said in the article, MAR6 mini circuits. And I'm wondering if mini circuits made these devices for HP, and then HP put their own number on them, but whatever. And the second device, which has just got a dot on it, in mine, is also an MSA 0685 again. I did get one thing wrong. The voltage regulator, I thought maybe it's a transistor, maybe there's a Zener down there. It's not. They've done the job properly. They've put a 6-volt LM 7806 in there, and the diode is just reverse power protection, feeding the input of the regulator. And apart from that, what more can I say at that point? I think it'd be best just to have a look at this article. Shame I can't read it, but we'll get the general idea of how it all works. So, here is the article, and the magazine, I think, is called Electour, and it's a 23 centimeter ATV. I think this would have been in the days of analog TV. So this was 1996, by the way. This appeared in the magazine. Just drinking coffee as well, and there it is. And that's a perfect, you can't see it because it's dark, perfect image of the one I have here. A Voorversterker. Wow, that's quite a word, isn't it? But I'm not Dutch. Anyway, here's the specifications, and I can more or less work out what they mean. Gain 35 dB. That is interesting because when I first measured it, I was only getting about 30. But I think I was doing something wrong with the spectrum analyzer, because when I did some more measurements yesterday, I was getting up to 36 dB. That's a hell of a lot of gain. And then I think this means Riesgettel, well, that'll be noise figure, less than 1 dB, I think, MGF 1302. Frequency range 1250 to 1300 megahertz. That's about what I was measuring. Center frequency 1285 megahertz. Current draw 60 milliamps. I was drawing about 40, I think. So there you go. That's the specifications. Scroll down a bit. Not sure how clear this is coming out, but I see they mentioned the word GASFET there, which is of course the first device. And they, I think that's here, it's a 6 megahertz 5.5. They're talking about the bandwidth of the ATV signal. Much like analog TV, it's fairly wide. And then they talk about 950 to 1750. That's for the satellite TV receiver. I can work that one out. So yeah, that works out, because the 23 centimeter band would be between those two frequency ranges. I'm not going to bother with any more of this. Here's the circuit diagram, schematic, whatever you like to call it. And well, what can you say? Signal comes in, there's the GASFET, and they're measuring at point A 0.85 volts, and I think that's what I measured. But what I did notice is that the gate's earth, basically, so you're getting negative bias on the GASFET, which is confirmed in the datasheet for that FET. You need to negatively bias it to set your drain current and source current, and then it's connected into the very high impedance point, so presumably a high impedance at that point, and that's the first element of the filter, which is tuned with, what's that, 5 PF capacitor, PTFE, by the way. They say PTFE trimmers, which makes sense at those frequencies. Still drinking coffee. Then you've got the next element of the band pass filter, and that in turn passes on to the third element. High impedance at that point, low impedance earth at that point, and that's tapped off at 50 ohms, because the next two devices are the MSA 0685s, and they're gain blocks with 50 ohm input and output impedance, roughly, not perfect but near enough. And they're run with 4 volts on the output, and and this resistor sets the voltage on the device. The same for that one as well. So having got loads of gain in the GASFET, you've got even more gain coming out here, possibly compensating for the loss in the filter. Then that passes on to the last one, which is again MSA 0685 Hewlett Packard or MAR 6 by millisecond. That's the power supply. Sorry if the table's wobbling. Anyway, more coffee. So, power supply is coming in via the output socket. I think it's roughly 14 volts, but anything really, as long as it's a couple of volts above the voltage of the 6 volt regulator, that will work fine. That's where you get your 6 volts comes out, and that's the schematic. All makes perfect sense when you see it like that. And what does all this mean? Microstrip filter, fine. GASFET van Mitsubishi Tujpask, something like that anyway. Mitsubishi GASFET anyway. And there you go, that's your construction details. How you wire it up, which is not an easy job due to the tiny little coils you have to make. More coffee, and you even get the artwork for making a PCB, which is all very good. Some clever chap designed all this. I don't think I could. And what else can we say? That's how you could make the GASFET. And they've used disc capacitors mounted straight on the earth ground plane. Bias comes in there, I think. No, that's down to earth from the source. Yeah. Then you got your coil, and they've done a really good job of this because they're not relying on one coil here and the ferrite bead. Because that could have capacitance across the turns, which would make it not such a high impedance at very high frequencies. So they've added little tiny coils that will work effectively at the higher frequencies to block any RF getting through. And that's how you mount it all. And there's your parts list on the left there. Which is fairly self-explanatory. GASFET MGF 1302, IC1, IC2, MSA 0865, Hewlett Packard of MAR 6, I think that must mean or MAR 6 mini circuits, and BNCs and whatever and whatever. And back over here is what it should, the bloody camera. That's what it should look like anyway, when you built it. I'm not sure how clear that comes out. Anyway, and that's the back of it, with the trimmers for the filter. And that's the end of the article. So all has been explained due to that kind person in Amsterdam, where the tulips come from. So not much else to say on that, but we could look at the individual devices used. Okay, this is the data sheet for the gas FET. Low noise, gas FET. Noise figure 1.4 dB at 4 gigahertz. Gain 11 dB at 4 gigahertz. So on 1.3 gigahertz, it's gonna have massive gain and probably a lot lower noise figure. Trying to find data sheets, graphs. Noise figure, frequency, noise figure, noise figure to ID current. This is frequency, and noise figure. Well, they don't extend the graph down to 1 gig or 1.3, but that's the noise figure on that. But it's heading in the right direction to be below 1 dB there. And I'm not sure there's any gain figures. I think you can work it out from this somehow. Okay, I think this one will give you the gain 1 gigahertz, 23.8 dBs of gain. Hell of a lot of gain. So there you go. Nice figure. 1 gigahertz, 0.77 dB. So it's pretty impressive. That's that. Right, now we're looking at the next device, MSA 080685, 50 ohm gain block, 3.5 volt typical voltage, 3 dB bandwidth, DC to 0.8 gig, high gain, 18.5 dB of 0.5 gig. That's how you wire it up. DC blocking in there, bias comes in the output, 3.5. You can have an RF choke and a bias resistor. You can get away with just a bias resistor, but it's better to have a choke as well. That's the way I would do it. And what do we find here? Power gain at 0.1 gig, power gain at 0.5 gig, 18.5 dB. So it's got quite a bit of gain. There's probably some graphs for that. Let's find the graphs. Power gain versus frequency. So at 1 gig, it's going to have about 17 dB, 16 maybe, of gain. More than enough for this circuit. They're not particularly good noise figure on these devices, but that's not their intention. The noise figure is determined by the gas FET at the beginning. So that more or less explains those two, and that's about that. But I did another measurement of it yesterday and I got slightly different results, and I did do a screenshot so we can have a look at that. So what we're doing here is I have anyway, I swept it from, I think it was 750 to about 1.5 gigahertz, I think, with a center frequency of 1.3 gigahertz, and I'd measured the gain across the peak sort of gain area and the frequency, and in the bottom you can see the markers. Marker 1 is at 1.2 gig, and that is 29 dB, and that's there. Marker 2 is 1.250 gig, 35 dB. It's coming up, massive amount of gain. And that's just there. And marker 3, about the same I think, 1.3 gig, it's 35.95, nearly 36 dBs of gain. And the last one is marker 4, which seems to have a little bit of a peak, and that is on 1.35 gig at 36.7, nearly 37 dBs of gain. That is a tremendous amount of gain. I really am surprised the little box keeps its stability and doesn't go insane with all that gain in it. But what I have proved is it's working as it should do according to that article. They're specifying about 35 dB, and it's got quite a nice broad bandwidth which would cover the whole of 23 centimeters. And I think that's more or less the end of the video. The mystery's been resolved anyway of what this thing is. I don't think I'd know what to do with it. For one thing, I'd have to get rid of some of the gain. I'd have to probably get rid of about 25 dBs of gain if I was going to use something like this on a 23 centimeter aerial antenna. But from this location, 23 centimeters is a complete waste of time. I gave up on it about 5 years ago. The hills are too obnoxious, that's a good word. Although I'm reasonably high up, I've got hills all around which are higher. So I tried 23 centimeters for a while. Furthest contact I made, 50 miles, gave up after that, waste of time. So once again, thanks for watching, and special thanks to the guy in Amsterdam who sent me the information on this. Okay, bye for now. Oh, I nearly forgot. I can buy one of these gas FETs, should I desire to. They're only £19.75 on eBay from a UK company, and postage is £2.75. I don't think I'll be buying one of those somehow. What a price though for a little tiny transistor FET, whatever. Incredible, isn't it? Anyway, bye for now.